Here we're looking at elementary statistics, section 9.4, talking about two dependent samples matched pairs. So once again, we're comparing the mean of one sample to the mean of the other sample, but they're going to have some sort of matched quality to this, okay? In the first example here, we're going to look at number 12. Okay, so on number 12, we talk about having a firstborn and a secondborn set of twins. Okay, so we talk about the brain volumes of twins. Okay, so we have brain volumes of twins. And it said lists below are brain volumes in cubic centimeters of twins listed in data set 6 of Appendix B. We want to construct a 99% confidence interval estimate of the mean of the difference between the volumes of the firstborn and the secondborn twins. What does the confidence interval suggest? Okay, so we're looking at this list. So on our list, what we need to do is we will need to go into a new document. Once again, we always like that new document so we get rid of any previous variables. We're going down to a list in a spreadsheet. In which then I'm going to come up here and we have our firstborn and then we have our secondborn. So I'm just going to label as an F and an S. Then I'm going to go through that list of the firstborn. So we have 1005, we have 1035, 1281, 1051, 1034, 1079, 1104, 1439, 1029, and then 1160 for our 10th one. So we're given 10 sets in here. Now, it's imperative that when we go to the secondborn, we want to make sure that we're matching up. So we have 963 goes with that 1005. Then we have 1027, 1272, 1079, 1070, 1173, 1067, 1347. Once again, just kind of double check. Goes with that 1439. Okay. Then we have 1100 and 1204. Okay. So we're given our listed sets of data. Now, what we want to do is we have to go up into our third column here. Okay. And in this column, I'm going to label this as D. Okay, this is my difference. Okay, now what I want to do here is I need to take my columns. Okay, so I need to take the difference of my columns. So what I'm going to do is I'm going to type A minus B and hit enter. Okay, so what this is going to do is this takes every number in column A and subtracts off column B and then lists it over here. So we can go through 1281 and then 1272, difference of 9. Here we have 1051, 1079, so a negative 28. So we have our difference column. Okay, and that's how we do it. So once again, we have to take our column name of our A, column B, and then it's going to subtract each of our values in here. Now that we have this, we have our difference in here, we can go over to our home menu and we bring into a calculator. Now I can do calculations within here, but it's easier to see in this calculator formatting versus the spreadsheet formatting. So just so you are realize that's why I go to the calculator mode, but we could do it within the spreadsheet. We go menu, statistics. Once again, we want a confidence interval and we just want a t-interval, okay? Because we're just going to be comparing one set of data in here that we're working with. So in the past, when we only had one set of data and we had to find our confidence interval, we could have been doing this all along, but once again, I had you do it by hand to appreciate the calculator at this given point in time. So this t-interval, once again, we're going to be bringing in data. We don't have the stats on this. Now, we could have calculated the stats out and then brought that in, but we're just going to bring in our data. Once again, it was our list D for our difference. And then it asks us in here that we want to have a 99% confidence interval. Okay, so we want a confidence interval of 99%. So I'm going to go 0.99. And then I hit enter. So what we see is that we have a lower bound, so our confidence interval is negative 66.748. We can go cubic centimeters, less than the mean difference, less than our upper bound then is 49.748 cubic centimeters. Okay. So what can we start concluding about this? Basically, we could start looking at this and we see that this does contain 0. So it does contain 0. So I'm just going to do like a little note over here. Does contain 0. Okay. So because this contains 0 means that we do have equality between the brain volume of the first and second twin. So depends upon what we're testing towards. We could be testing towards the simple fact that maybe we would have the first twin born has a larger brain, and the second one has a smaller brain just because of development, that it's further developed. There's different things we could start concluding about this. The smaller brain size means the smarter you are, so the second twin's smarter than the first twin. There's a whole bunch of different things that could be started concluding about this, but this is basically how we use this confidence interval to work with these problems. Now, I'm just going to go through, and once again, we could use a hypothesis test on here. Within this hypothesis test, once again, we would go down to our statistics, our stat tests, and then we would run a t-test on here, once again using our list of data. On here, it would ask for what are we comparing this to, okay? So what are we comparing our mean to? In this case, we would state 0, okay? So when we use our stat test, we're comparing that our difference equals 0. Then we're using our lists of D. And then in this case, it asks for a 99% confidence interval. So if we go back to our table, 99% confidence interval talks about a two-tail test with a significance of 0.01. So 99% confidence interval talks about a significance level of 0.01 and a two-tail. Okay? So in our hypothesis test, our null hypothesis, our difference equals 0, and then our alternative hypothesis here, we would talk about that this difference does not equal 0. Okay, so once again, this is how this hypothesis test would be going for this. And we could change it to be other values in here, but this is the most common way with this one to use it, so that's why we're using it. The reason why we can enter this value in here is we think back, we did this exact same t-test for other lists when we talked about different values in here. So it would have been those other values that we would have typed in here. So once again, we have under hypothesis test, we have the 0. We're bringing in our difference list, and then we got a two-tail just because of that 99% confidence interval. Generally talks about a two-tail with a significance level of 0.01. So we come in here and we see that we have our t value, so our test statistic is t equals negative 0.474. Our p-value is 0.646624 in there. So once again, if we think back significance level here, we would fail to reject. So we fail to reject the null hypothesis. Once again, the null hypothesis was showing equality. Back here, we're showing the same thing. So depends upon situation and what is required from us. Once again, we could run one or the other. Depends upon, once again, the list that we're in reference to. So let's do another example. In this case, we'll do the hypothesis test first, and then we'll come back and also do the confidence interval so we can just kind of double check what's happening in here. Let's go to number 16. Okay, On number 16, we're talking about self-reported heights and measured heights of male heights. Okay, so self-reported, and then the actual heights of males. Okay, so as part of the National Health and Nutrition Examination Survey, the Department of Health and Human Services obtains self-reported heights and measured heights of males aged 12 to 16. All measurements are in inches. Listed below are the sample results. Construct a 99% confidence interval estimating the mean difference report between the heights and measured. Interpret the resulting confidence interval and comment the implication of limits containing 0. Okay, so once again, tell us confidence interval. I want to do a hypothesis test first, and then we'll do our confidence interval on this. So first things first, we have to basically go into a new document. Once again, that new document eliminates our old one, and no, we don't want to save any changes. Okay, so we're going to go into our list and spreadsheet. Once in this list and spreadsheet, we're going to type into our reported. So I'm just going to go R for our reported. And then our measured heights would be this other one, so let's go M. And then we could label our third one as our D. Once again, we're going to need that difference in here because they're matched pairs. So we see that the reported heights go 68 inches, 71 inches, 63, 70, 71, 60, 65, 64, 54, 63, 66, and 72. So we have 12 total in here. Now we come to the measured heights that it would be, and that 68 inches truly was measured at 67.9 inches. The 71 was really 69.9 inches. 64.9 inches was at 63, so somebody thought they were shorter than they actually were. The 70 inches was really 68.3, 70.3 for the 71, 60.6, 64.5 for the 65, 64 was really 67.0, 55.6 was at 54, 74, 0.2. So we had somebody thought they were 63 inches tall, and really they measured at 74.2 inches tall. Yeah, either somebody isn't the brightest crayon, or they truly were just trying to mess with somebody. And then we have our 72 inches goes to 70.8. So let's kind of type in that list of data. Once again, matched up all 12. Going to come over here now. What we want to do, once again, we're in our equal line here. We're going to go A minus B. So once again, column A minus column B. And then we get our difference in our values right here. So now we're going to go over to our calculator, and we're going to be running our test. So let's state what we have here. So for a hypothesis test, our null hypothesis, we're going to talk about the fact that the difference equals 0. Okay? Now, it asks us, and we start looking in here, confidence interval estimate, the mean difference, the reported heights and measured heights. So we're just talking about the difference between them. So are they equal or are they not equal? So basically how people are. So our alternative test in this case would be not equal to. Okay? And once again, they talk about a 99% confidence interval right here. So if we were to go back, a 99% confidence interval talks about a significance level of 0.01 under a two-tail, which makes sense that this would be not equal to because of that two-tail. So that's another way that we could interpret it. That if we talk about those confidence intervals and we want to go to a hypothesis test, we could take that value in here, once again, go back to that table on page 399, kind of has the main interpretations of most of our ones in here. So considering that, then, we would run our test. So we would go menu, statistics, stat test, t-test. We're using data. We're comparing to 0. Once again, our null hypothesis would be a difference of 0. Our list was list D. And our alternative is they do not equal. So then we come in here and we see that we have a test statistic of negative 0.984. I should go t equals in there. Always want to state what value we're using, because remember, for that mean, sometimes we could have z if we knew population standard deviations, which is very rare, so that's why it's a t in here. And then our p-value is 0.346. So we see that we fail to reject the null hypothesis. So meaning that there is not sufficient evidence to reject the claim that what people report and actually measure is true height. Okay, so once again, we can't support this claim because the claim is our null hypothesis. So that's where we got to go backwards in this. Now, considering the fact that if we just want to do a confidence interval, okay, so then I didn't write anything in here. This was all extra, so you can see that hypothesis test in here. We didn't necessarily have a hypothesis to go off of, so it just told us a confidence. So we go menu, statistics, confidence intervals, t-interval, data. Here we would enter in our list D, and we'd want a 0.99 confidence. And then we see in here that, so for our confidence interval, we would have negative 4.1555 inches, less than the mean difference, less than 2.1555 inches. Okay, so kind of concluding what this is going on, once again, we see 0 is in here, so we're seeing the fact that because the confidence interval contains 0, there's not sufficient evidence to support the claim that there is a difference between self-reported and measured heights. Okay, so this means we might believe that males would tend to exaggerate their heights, but given this data, do not provide enough evidence to support that belief. So basically, what this is telling us in general terms is that males, when they state what their height is their actual height that they're reporting towards. They're not saying, oh, I'm so much taller than what I really am. It's kind of showing that in there. And that's kind of what our conclusion would be. Once again, I'm not going to write that out. You can go back and rewatch the way I read it and said it. All kind of depends upon what the claim is in here. And the confidence interval kind of allows a little more freedom to what we want to support and what we don't want to support. This hypothesis testing over here is kind of set to find how we state our answers in here. Once again, if we're citing here or citing here. In this case, we're kind of a little bit more for freedom on what it is, but a lot of times we could use this stating to back up whatever we want to state here, because they will give us the same results.